Good morning, dear students. I welcome you all to this class. Today we will see mathematical derivation of first law from second law. Earlier we learned first law of motion and second law of motion. Today we will see how to derive one law from another law. Okay. So here we see mathematical derivation of first law from second law. We have second law, that is F equal to ma, force equal to mass into acceleration. From this law we will derive first law, that is law of inertia. Okay, so let us start. The first law of motion can be mathematically stated from the mathematical expression for the second law of motion. So there is a relation, mathematical relation, between the first law of motion and second law of motion. If second law of motion is given to you, then mathematically you can find out the first law of motion. Okay, so this is the second law of motion, mathematical formula or mathematical derivation. Force is equal to mass into acceleration. Now here you should keep in mind that this force is equal is unbalanced force. Okay, so let me repeat here what is balanced and unbalanced force. If this is a body, if a force is applied here, okay, irrespective of the value of the force, okay, now the force may be different. Suppose I'll give you another example to make this one understand. Suppose this is a body, force is applied here. After the application of force, if the position or the motion of the body is not changing, that means even if the force is applied to the body is still balanced. So in this case, this force has balanced force. Okay, suppose here 2 Newton force is applied, the body is not changing, the body does not change, neither its position or motion. 4 Newton force is applied, still the body remain in its same position and its situation or motion. Then here both the 2 Newton force and 4 Newton force, both the forces are known as balanced force, because for both the forces the object or the body still remains in its original position. Okay, now if 10 Newton force is applied on the body and the body start moving, then in this case 10 newtons become unbalanced force. Why? Because the 10 Newton force has made the body move from its original position. Okay, so here force is equal to mass into acceleration. What is acceleration? We know that v minus u by t. I've already explained you how acceleration is equal to v minus u by t in the previous videos. Okay, that is v equal to u plus at, v equal to u plus at. From this you can derive that a equal to v minus u by t. Now if you bring this t here and multiply it with force, so F into T is equal to mv minus mu. Now what is mv? Yesterday we saw mass into velocity is momentum, that is final momentum, this one. Mu, initial momentum. So here the body is moving initially with speed u. F force is applied for the time t. So after this application of F force for the time t, the speed of the body changes to v. So its final momentum becomes mv. The change in momentum is equal to final momentum minus initial momentum. That is, when F equal to 0, if we consider F equal to 0 here, suppose F is equal to 0. Now 0 into t becomes 0. Okay. So when F equal to 0, this terms becomes 0. So when this terms becomes 0, it will be 0 is equal to, if you take a mass common from here, it will be v minus u. Okay, now if you divide mass with 0, 0 by m will become 0. So 0 is equal to v minus u, which implies that v is equal to u. So which is first law of motion. Now, what is first law of motion? Unless and until an external force is applied on the body, there will be no change in the body, neither its position nor its speed. Okay, so for what, so that is when f equal to 0, v equal to u for whatever time t is taken. This means that the object will continue moving with uniform velocity. Now, when initial velocity and final velocity are same, that means the body is moving with uniform velocity u throughout the time. Now, throughout this time t, when force becomes 0, the body will move with same velocity. If u is 0, then v will also be 0. Here we are considering that initially the body is moving with speed u, velocity u. There is no external unbalanced forces applied on the body. So after certain time, the body is also moving with same velocity or same speed. If u equal to 0, that means the body is at rest position, is in rest position. After time t, it will also be in the rest position. Okay, that is the object will remain at rest, which is first law of motion, that the object will remain at rest. If it is at rest position, it is in motion, it will be in motion if it is in motion, unless and until some external unbalanced force is applied, which makes the body stop or makes the body move. Okay, so this is the derivation of second law of first law. From first law, this is very important. You should always practice this one. One of the most important question from your examination point of view. Okay, so here I mark it very important. Derivation of first law from second law. Practice this one. Okay, so now let us solve some of the questions. This is example 9.1. You can see it in your book. A constant force acts on an object of mass 5 kg. What are the given data? While solving question, first you note down what are the given data. Mass is given 5 kg. So we have mass. Mass is given. During 2 seconds. Time is also given. Okay. A constant force acts. What is the value of constant force? It is not given. Okay. So constant force, suppose F is the force acting on a body, acts on an object of mass 5 kg. Mass is given. Time is for time time is given. It increases the object velocity from 3 meter per second to 7 meter per second. So initial velocity is given. Initial velocity is 3 meter per second. Final velocity is given, that is 7 meter per second. Find the magnitude of the applied force. Here what you need to find out, what is the value of the force. Okay. Find the magnitude of the applied force. Now if the force, so this is second part of the question. So first to solve first part. So you know that F is equal to, from second law of motion, mass into acceleration. In place of acceleration, you can write V minus u divided by t. Okay, you put all these respective value, you will get the value of F in terms of Newton. So because all these are given in SI unit, so whatever the value you will get, that it will be in terms of Newton. So what is mass here? Mass is 5 kg. 5 into V minus u. V is 7. U is 3. 7 minus 3 is 4 divided by time. What is the time here? 2 seconds. 2. So this will be 2. 5 into 2 will be 10 Newton. Okay. Now second part of the question. Now if the force was applied for a duration of 5 seconds. Now the force we have calculated. Now it is saying that if this 10 Newton force, rather than it is applied for 2 seconds, if it is applied for 5 seconds, what would be the final velocity of the object? So here we need to find out in the second part of the question, what are the given data. That force is 10 Newton. Mass of the body will not change. Mass is 5 kg. Initial velocity is 3 meter per second. Final velocity we need to find out. Time is 5 seconds. What is final velocity? Same, you need to calculate this one. Same process. This is the formula for this question also. In place of F, write 10. In place of mass, write 5. U, 3. T, 5. Solve this one. You'll get the value of V. Okay. So this is all about this question. Let us solve some other questions. Which would require a greater force? Accelerating a 2 kg mass at 5 meter per second square or 4 kg mass at 2 meter per second square. So which would require a greater force? So here two cases are given. You need to calculate F1 and F2 and compare which one is more. So in first case, if this is first case, this is second case. So accelerating a 2 kg mass, we have 2 kg mass. Here acceleration will be 5 meter per second square. 4 kg mass, acceleration is 2 meter per second square. Now you know that force is equal to mass into acceleration. Force is equal to mass into acceleration. So in first case, what is mass here? Accelerating a 2 kg mass at 5 meter per second square. So in first case, mass is 2 kg, acceleration is 5. So 2 mass into acceleration, m into a 2 into 5, that is 10 Newton. F1 is equal to 10 Newton. In second case, F2 is equal to 4 kg mass, 2 meter per second square acceleration. So 4 into 2. 4 into 2 is 8. This is 10 Newton. This is 8 Newton. Now here F1 is more than F2. Okay, so the first case it requires more force. Okay. Very easy question. Next question. A motor car is moving with a velocity of 108 meter per second, sorry, kilometer per hour. Okay. It takes 4 seconds to stop after brakes are applied. Now you see, here the units are given in kilometer per hour. Here the unit is given in second. So here what you do, you convert this kilometer per hour into meter per second. So here initial velocity of the motor car is 108 kilometer per second. If you want to change it into meter per second, 1 kilometer is equal to 1000 meter. 1 hour equal to 3600 second. 3600. So you solve this one. After solving, you will get a value in meter per second. Now brake is applied for 4 seconds. Time is 4 seconds. Calculate the force exerted by the brakes on the motor car if the mass along with the passenger is 1000 kg. Here mass along with passenger. Passenger are sitting inside the motor car. Okay, they are not flying over the motor car. Okay, so we include all the masses. So mass is 1000 kg. This is also very easy question. Now see, a motor car is moving with a velocity of 108 km per hour and it takes 4 seconds to stop. This is important. To stop. Initially the motor car was moving. After application of brake, it stops. When it stops, that means final velocity is 0. Okay, so suppose this is river or pond, whatever it is. It's a motorboat. It is moving with 108 km per hour. A brake is applied, and after certain time it will stop. So here final velocity becomes 0. So here you need to calculate the force. Same, force is equal to mass into acceleration. So force is equal to mass, that is 1000. Acceleration is equal to v minus u divided by t. Okay, so solve it and try to find out the answer. Okay. Next question. A force of 5 Newton gives a mass m1 and an acceleration of 10 meter per second square and mass m2 and acceleration of 20 meter per second square. What acceleration would it give if both the masses were tied together? Okay, so there are two different cases combined with each other. So let us solve. A force of 5 Newton gives a mass m1. Okay, now this is a mass m1. In this mass m1, a force of 5 Newton gives a mass m1 an acceleration of 10 meter per second square. If there is a body whose mass is m1, in this body 5 Newton force is applied. When 5 Newton force is applied in the body, its acceleration, it acquires an acceleration of 10 meter per second square. Okay, there is another mass m2. The same force, a force 5 Newton gives a mass m1 an acceleration 10 meter per second square and a mass m2 an acceleration of 20 meter per second square. Same force is applied on another mass m2 where this mass acquires an acceleration of 20 meter per second square. What acceleration would it give if both the masses would tie together? If you combine these two masses m1 plus m2, if you combine it and if you apply the force, okay, what is the force? 5 Newton. Then what will be the acceleration of the combined mass? This is a very interesting question. Okay, try to solve it on your own. Okay, try to solve it, otherwise I will explain this question in the next class. One of the most important questions. This is also very easy and very interesting question. Try to think and try to solve. Okay, let us move to this question. Velocity time graph of a ball of mass 20 gram. See, there is a ball whose mass is 20 gram moving along a straight line on a long table is given in the figure. This is velocity, this is time. How much force does the table exert on the ball to bring it rest? So here data is indirectly given rather than directly. Now see, this is the initial velocity, this is the final velocity. So initial velocity of the body is 20 centimeter per second. Okay, now see, this is centimeter per second, it is given here. Okay, final velocity is 0. So initial velocity is reducing to 0. That means brake is applied on the body. It is like that a body is moving with certain speed, brake is applied, after certain time the body comes to rest position. Those type of question. That type of question. So mass of the body is 20 gram. Initial velocity is 20 centimeter per second. After 10 second, when the brake is applied, the body comes to rest position. Okay. So what are the given data? Let us write once. Mass of the body is 20 gram. So here there is no need to convert all the data because all the data are given in CGS unit, that is centimeter, gram, second. Okay. So if it is given in meter per second, then you would have converted into kg. Okay. So CGS, G for centimeter, G for gram, S per second. Okay. CGS. Okay. One is this unit, CGS unit, centimeter, gram, second. One is SI unit or MKS unit, MKS. Okay. So here in SI unit, mass should be in kilogram, velocity or speed should be in meter per second, and time should be in second. Okay. So there is another unit, FPS, foot pound second. So that we do not use FPS unit in India. In Western country it is used. Okay, so let us solve this question. Mass is given 20 gram. Initial velocity of the body, it is 20 centimeter per second. Final velocity 0, because finally the body is coming to rest position. This one. Time, what is the time required from here to here? 10 seconds. See here, see the unit in second it is given. Okay, so this is from this graph we can extract this data. Now the question is, how much force does the table exert on the ball to bring it to rest? So in this case, what is the applied force? Very easy. Force equal to mass into acceleration, where acceleration can be written as v minus u by t. So m into v minus u divided by t. So what is mass here? We put all the respective value, okay, and calculate and try to find out the force. Okay, here this formula I have written m into v minus u by t. These are all the given data. You just put the data here and calculate it. Okay, this is also one of the important question. So this is all about today's class. In the coming class, we will start third law of motion. Okay, so thank you and have a nice day.